All right, let's dive into a deep dive today all about volcanoes.
Sounds good.
We're going to be looking at some research from Cornell University that was featured in SciTech Daily called Scientists Stunned. Large magma bodies found beneath sleeping volcanoes. And the thing that I thought was really interesting was this idea that dormant volcanoes maybe aren't as asleep as we might think.
Yeah, that's a really interesting way to think about it. And this research is really helping us kind of challenge our own assumptions about what's going on underneath those seemingly, quiet mountains.
Yeah, so the researchers used seismic waves, which is kind of like doing an ultrasound on the Earth to peek beneath 6 volcanoes in the Cascade Range. And some of them were active and some hadn't erupted in a really long time. And what they found was pretty surprising.
Yeah, absolutely. They found these large magma bodies just kind of lurking beneath all 6 volcanoes, which, at first might not sound that earth-shattering, but it kind of goes against what we used to think about how magma chambers work. We used to assume that they gradually empty after an eruption, and then they just kind of refill when the volcano is about to erupt again.
So instead of these magma chambers being kind of like a temporary holding tank, they're more like a persistent reservoir that's just kind of simmering under the surface.
Yeah, exactly. And that's a pretty big deal for how we think about volcanoes. And it makes you wonder a little bit, right? If you think about somewhere like Crater Lake in Oregon, it's so peaceful and picturesque, but then you realize there's this massive reservoir of molten rock just sitting underneath it.
Yeah, it's like finding out your quiet neighbor has a basement full of fireworks. They might not be setting them off right now, but, the potential is there.
That's a great analogy, and it has huge implications for how we monitor volcanoes and try to predict when they might erupt.
Yeah, because if these massive magma chambers are just always there, how do we know when one is actually about to erupt?
That's the key question, right? The presence of a magma chamber by itself doesn't mean that an eruption is imminent. It's more about understanding how the conditions within that system are changing. Think of it like a pot of water on the stove. Just because there's water in the pot doesn't mean it's boiling. You have to look for other signs, like are there bubbles? Is there steam to know if it's actually getting close to that point?
Okay, so what are the signs that volcanologists are looking for? What are the bubbles and steam, so to speak?
So one of the key things that we look for is ground deformation. As magma moves around inside that chamber, it can actually cause the volcano to change shape just ever so slightly. We're talking millimeters, sometimes even less. But with the right equipment, like GPS and satellites, we can actually detect these tiny changes. It's almost like the volcano is breathing.
Oh, wow, so it's like the volcano's kind of inflating as the pressure builds up inside. That's a little eerie, isn't it, to think that the ground beneath our feet is constantly shifting and changing because of these forces. And these magma chambers have probably been hanging out under these volcanoes for like millennia.
Absolutely. These are processes that take place over timescales that are way beyond our human comprehension. It's pretty humbling.
It really is. It makes you realize how much we still don't know about our own planet.
And this discovery about these persistent magma chambers, it's a perfect example of that. It's forcing us to kind of rethink our assumptions and come up with new ways to understand these really complex systems.
Okay, well, I think we should take a break and then we'll come back and we'll talk a little bit more about what scientists are looking for when they're monitoring volcanoes for possible eruptions.
Sounds good.
So we've got these like silent giants with these hidden, reservoirs of molten rock underneath them, and the ground is shifting around because of that. What other signs are scientists looking for to try to figure out if one of these things is going to erupt?
Well, in addition to that ground deformation we were just talking about, changes in gas emissions can be a really big indicator.
Right, because magma releases gases as it rises, right? Like sulfur dioxide, carbon dioxide, things like that.
Exactly. It's kind of like when you open a can of soda, all that pressure has been building up inside, and then when you release it, all the gas escapes, you get that fizz. And it's kind of similar with magma. As it rises towards the surface, it starts to release those gases, and we can actually detect them at the surface.
So how do scientists monitor that? Are they like hiking up to the crater with gas masks and like test tubes and stuff?
Well, there are still some ground-based monitoring stations, but technology has actually come a long way. We can use drones these days and even satellites to measure gas concentrations remotely.
Oh, wow. So it's like we've got eyes in the sky constantly watching these volcanoes for any changes.
That's a great way to put it, yeah. And with the help of artificial intelligence, now we can analyze all of that data in real time so we can start to see patterns and anomalies that might suggest an eruption is coming.
So it sounds like volcano monitoring is getting pretty high tech.
It really is, yeah. We're moving from, just basic observations to these really sophisticated data analysis techniques and predictive modeling.
And this research about the persistent magma chambers, I imagine that's adding like another layer of complexity to all of this, right?
It definitely is, yeah. Because, we used to think that if we saw a big magma chamber under a volcano, that meant an eruption was probably about to happen. But now we know that that's not always the case. These chambers can stick around for a long time without any kind of fireworks.
So instead of just looking for the presence of magma, we need to try to figure out how that magma is behaving.
Exactly. Is it moving upwards? Is it interacting with any groundwater? Those are the kinds of things that can give us clues about the likelihood of an eruption.
So it's much more nuanced than just, seeing a big pool of magma and sounding the alarm bells.
For sure. And this has implications beyond just the Cascade Range. This is something that we need to think about for other volcanic regions around the world, too.
So if we're seeing these persistent magma chambers in the Cascades, could they be lurking under other volcanoes as well?
That's the big question, right? And if this pattern holds true in other places, it could totally change how we assess volcanic risk globally. It's really exciting and a little bit scary, too.
Yeah, it really does make you wonder, like, if we're finding these things in the Cascades, what about other volcanoes around the world? Are these persistent magma chambers lurking under those sleeping giants in other places?
It's the million-dollar question, right? It's like we've been looking at volcanoes with one eye closed this whole time, and now we're finally starting to see the full picture.
So where do we go from here? Like, if this research is as groundbreaking as we're saying it is, what happens next?
Well, the next step is to try and figure out if this is a pattern that we see in other volcanic regions, too. We need to look beyond the Cascades and start studying volcanoes in other geological settings. Like, what about the Ring of Fire?
Oh, yeah.
That's that circle of volcanoes around the Pacific Ocean, and there are hundreds of volcanoes there, and a lot of them are considered dormant.
Oh, wow. Imagine if we find these persistent magma chambers under those volcanoes, too.
Right? It could completely change how we think about volcanic risk around the world.
Yeah.
And the good news is we have the technology to do it. With things like seismic imaging and remote sensing getting better and better, we can actually do these kinds of investigations on a much larger scale than we ever could before.
So we're talking about like a paradigm shift in volcanology.
Yeah, I think so. It's like we're entering a new era of volcano research.
And for people listening to this, it means we need to rethink what we consider a dormant volcano. Just because a volcano hasn't erupted recently doesn't mean it's not capable of erupting again someday.
Exactly. We can't be complacent. We need to stay vigilant, especially if we live near volcanic areas. Knowledge is power, right?
Absolutely. The more we understand about these forces of nature, the better prepared we'll be to coexist with them. And who knows what other amazing things we'll discover as we continue to explore and learn about our planet.
Exactly.
Well, that's about all the time we have for today's deep dive into the world of sleeping volcanoes. I hope you found it interesting and maybe a little bit thought-provoking. Remember, those quiet mountains might be hiding more fire than we realize. Until next time, stay curious.